Hello, everyone, and welcome to the module on science literacy. The entire course starts off with this module because it's the foundation of how we distinguish between high quality information and low quality information, and how we gather the knowledge required to have a scientific basis for our understanding of how to improve the body and how to understand nature and how to think critically. So all of those things are important, and we will begin with the outline of the lesson. Okay, so we're going to have 6 lessons within this module. The first one will define science and the scientific method. The next one will be defining science literacy and its role within evidence-based practice. Third lesson involves learning the types of research and their roles in the evidence hierarchy. Fourth lesson, we will navigate conflicting study results by using the PICOS framework. And then we're going to learn how to use a scientific search strategy to gather information. And we'll look at an example where we actually investigate a particular claim that may or may not be dubious. We'll see. And then finally, we'll discuss how to attain a scientific mindset or a scientific attitude or scientific ethos. And with that, let's start the first lesson. Defining science and the scientific method. Let's come out swinging with the big question. Why is the general public so confused about what to eat? First of all, everybody eats. This means that depending on who you are, depending on the size of your ego, maybe, there are plenty of opportunities to have a false sense of authority and emotional attachment to what happens to work for you. So since everybody eats, a lot of people have a tendency to feel like their authority on eating. Second reason that the general public is so confused about what to eat is because misinformation is rampant. And information in general can be either commercially or ideologically driven. And when misinformation is combined with ideology and or commercial interests, then it can get really messy. The third and final reason why the general public is so confused about what to eat is because science literacy is very scarce amongst the lay public. And it's also scarce amongst practitioners and coaches. So science literacy is actually scarce across the spectrum of populations. And we're going to tackle it, and we'll understand it, and we'll gain some tools and skills to become scientifically literate. All right, let's define science. According to the National Academy of Science, science is the use of evidence to construct testable explanation and prediction of natural phenomena, as well as the knowledge generated through this process. Kind of a mouthful, kind of an unwieldy definition, so I simplified it. My definition of science. Okay, well, science is the set of principles that guide research toward uncovering the truth without kidding anyone or yourself. It's important to make a distinction between science and research. Science encompasses the underlying principles and method, and in a sense, science, because it's a set of guiding principles, it's perfect. Okay, in quotes. Science itself as a set of principles is perfect. However, what's not perfect is research. This is because research is the vehicle that carries out the principles of science, and research is a human-driven vehicle. That means it's got all of the biases and the errors that humans inherently possess, and therefore research is inevitably imperfect. An important point, though, just because research, scientific research that is, just because scientific research is imperfect and has all the human flaws written all over it, this doesn't make it inferior to just whims, speculations, anecdotes, gossip through the grapevine. Scientific research is the best tool that we have for understanding the natural world. Let's talk about the scientific method. You probably haven't discussed the scientific method since fourth grade, but I'll try to make it exciting by using creatine in our example. So, the first step of the scientific method is observation and description of a given phenomenon or phenomena, if it's plural. So, what we can do with creatine is make the observation. This white powder, when you take 5 grams or so of it a day, every day, for a few months, it seems to result in gains in muscle size and strength. So that's the observation. And upon that observation, we can formulate a hypothesis. How about this hypothesis? 3 to 5 grams of creatine per day results in significant gains in muscle size and strength if the individual is engaged in progressive resistance training over a period of weeks or months, let's say 12 weeks. The third step in the scientific method is testing the hypothesis. So, with something like a supplement, we can take a classic parallel arm randomized controlled trial and run the experiment like this. So, there's an experimental group who's taking the agent that we're investigating, and then there's a control group or a placebo group that we use to make sure that we have suppressed all of the noise or the confounders and made sure all the variables are the same in both groups, except for the experimental treatment, which is the creatine, and the placebo treatment, which can be an inert substance like, let's say we'll use 5 grams of sugar, and we'll be comparing that to 5 grams of creatine. So we test the hypothesis through an experimental trial. And at the end of the rainbow, 12 weeks are done, we gather the data, analyze it, and evaluate whether there was a significant or a meaningful effect of creatine compared to the inert placebo control group. And whether or not we get a significant effect from creatine, for example, it's important to repeat the process. It's important for our findings to be replicated, preferably by independent labs who are not commercially vested. So the more replication that can happen, the more reproducibility of the results that our lab got, then the more confidence that we can have in the idea that, hey, this creatine stuff just might work. So, as you all probably know, it just so happens that creatine has hundreds and hundreds, maybe into the quadruple digits, of studies showing that it does cause a significant or meaningful effect in muscular adaptations to training and a bunch of other outcomes as well. So, that's a scientific method. Observation, formulation of a hypothesis, testing the hypothesis, analyzing the data, and then repeating the process so you can get replication. And hopefully, if the results are reproducible, then that increases our confidence that we really have found an agent that works. Well, that concluded the first lesson. And you're free to take a little breather, and then we'll get on to lesson 2, where we define science literacy and its role within evidence-based practice.